Hey, it's Mr. Barr, and this is the pretest for transformations. So let's get started with this. A line segment that is 7 centimeters long is rotated clockwise around the origin, then it's moved, it's translated down 3 units. How long is the new segment? It's still 7 centimeters long. Moving it around does not change its size. What transformation could you use to prove that A is congruent to A prime? So here's A and there's A prime. So if I do a reflection across the y-axis, that's a way I could prove that they are identical. So I chose reflect across the y-axis. What transformation could I use to prove that A is congruent to A prime? Well, there are actually 2 of them. I can either move this one to the left and then down, or I can move it down and to the left. Since the corners are not labeled, we do not have to match up the corners. So I guess we could also do a reflection and then move it down. So those are the 2. So reflect it across the y-axis and then bring it down 3. Translate it left 5. 1, 2, 3, 4, 5, and then down 3. So 2 options there. If the corners were labeled, we'd have to be a little bit more intentional with this. Triangle ABC is translated down 3 units and then left 5 units to form triangle A prime, B prime, C prime. Determine which of the following statements are true for A prime, B prime, C prime. Select true or false for each. Okay. AB is longer than side A prime, B prime. No, that's false. They're the same size. When I move this, the sides aren't going to change at all. AC is the same length as A prime, C prime. That's true. Everything's the same. AB is the same length as AC. AB is the same as A prime, C prime. No, those are different. This is saying that if I move it, that this suddenly becomes the same as that. No. So these are both false, and that one is true. Triangle ABC, this guy here is rotated 90 degrees, and then it forms this guy here. So match up the sides. So when I rotate this, I can see that AB is the same as X. AB is X. BC is the same as Y after that rotation. BC is Y. And CA is Z. That's what it looks like after those rotations. Describe a sequence of transformations that could be used to show that ABC is congruent to A prime, B prime, C prime. Okay. So notice here, as I go from here to here, the C is on the interior on both these, are inside, right, closest to the axis. So I need to do a reflection and then a translation down. I reflect it across because I have to get the points, the corners to match up, and then move it down. So first I can reflect it across the y-axis, and then I can translate it down 7 units. 7, 1, let me get a pencil. 1, 2, 3, 4, 5, 6, 7 units down. Parallelogram ABCD is reflected across the x-axis, so it brings it down here, and then translated up 2 units, and then translated 1 unit to the right. To the right, got it. Determine which of the following statements are true regarding the transformation. Select true or false for each. Okay. D has the same angle as W, so if I flip it over, D is right here. D is the same as W. D and W, no, this is obtuse and that's acute, so that's false. C and Y are congruent. Angle C, which is right here, which would be right here. Angle C and Y are congruent. Yes, they are the same angle. AD has the same length. AD has the same length as something. Let me plug my computer in so it doesn't turn off again. What was it? AD has the same length as ZW. AD, ZW. Yes, those are the same side. True. Okay. Focus, there it is. A rectangle is shown, translated down 3 units. The rectangle shown is translated down 3 units and then reflected across 1, 2, 3, 1, 2, 3, across the y-axis. Which of the following coordinates are corners of the new triangle? So translate it down 3 and then reflect it, and then we're trying to match up the corners here. So it's 5, 1. 5, 1 is a corner. -5, -1 is not a corner. -8, -6 is not a corner. 8, 6, 8, 6 is a corner. 0, 1 is not a corner, and 4, -4 is not a corner. Trapezoid ABCD is reflected across the x-axis. What is the coordinate of C? Really, all I have to do is just reflect the point C across the x-axis. So I just take this one point and reflect it across the x-axis, and I get 1, -2. 1, -2. And that's it for this one. Let's see how it works with Edulastic. Make sure that I have my Edulastic looking good, and that my answers are correct in Edulastic. Really, this part is just me checking my own work pre-test. So this is 7 centimeters. Reflect across the y-axis. And with those two. First, reflect across the y-axis. Second, translate down 7 units. %. Okay, so that one works. Thank you for watching, and I'll see you later.